Hello and welcome back to my channel where I solve mathematical problems. Here we are given this problem and we are told that the shape ABCD is a square, and we also given another square, which is a smaller square within that larger square with dimensions of 3 by 3, and we are given a circle inside of the square touching that smaller square at point E, let's say E, all right, with a radius r, and we're asked to solve for r. Before we get started, let's establish some facts about this shape. Since ABC is a square, therefore let's establish that this length is 6 and this length is 6, right? And we can establish that we have 4 squares in here, and each of them have length 3. And also, let's give this point here a G, and we know that all of these points lie along the hypotenuse. So in method number 1, we're going to consider two triangles, one which is BCD. So we have shape BCD, where this length is 6, this length is also 6, and this, let's call it H. This is the hypotenuse, all right? So we can solve for H, all right? And then let's consider this other triangle, which is EGC. Triangle EGC, where this equals to 3, and we know that this is the center of the circle right here, and so this would be R and this would be X. So we know that this hypotenuse is X plus R. So let's solve for H. We know that H squared is equals to 6 squared plus 6 squared, and H squared is equals to 36 plus 36, which is equals to 72. Therefore, the square root of H squared is equals to square root of 72, which is also equal to square root of 36 dot square root of 2 crosses out, that becomes 6, and cross out becomes H. Therefore, H is equals to 6 square root of 2. Now, we have similar triangles, so H and X plus R and 6 and 3. So let's do that. Let's go. H, which is here, equals to 6 square root of 2. So we have 6 square root of 2 divided by 6 is equals to X plus R over 3. Let's cross multiply. We have 6 outside of X plus R will equals to 3 times 6 is 18 square root of 2. Let's get the 6 out, then that'll be 3. So now we have X plus R is equals to 3 square root of 2. We know that X is equals to 3 square root of 2 minus R. So let's get back to this shapeware, and we know that this is X and this is R. So we draw a line here, Now this is R, this is R. So we have now another triangle, and this is R. So we have another triangle here. So let's do the same thing. We have this smaller triangle, here, r, and we see this x. Therefore, x squared is equals to r squared plus r squared, which is equals to 2r squared. And therefore, x squared, the square root of that is equals to the square root of 2 dot square root of r squared. It becomes r, it becomes x. Therefore, x is equals to r square root of 2. So now we have two values for x, here and here. Let's equate them. So we have r square root of 2 is equals to 3 square root of 2 minus r. Let's take this r and bring it the other side. So we have r square root of 2 minus r is equals to 3 square root of 2. And then we have r outside of square root of 2. No, that's plus 1 is equals to 3 square root of 2. Therefore, r is equals to 3 square root of 2 over square root of 2 plus 1. That's the value for r using method number 1. Method number 2, we're going to do the same thing. We're going to say this is, all right, we have the same line. This is x, and this has to be r. This is r, and this is r, right? Now, because this is a square, then this length is equals to this length. So we can say this total length here is equals to p. So therefore, using this square, we know that p squared is equals to 3 squared plus 3 squared. So that p squared is equals to 9 plus 9. P squared is equals to 18. So p squared, the square root of that is equal to the square root of 9 dot square root of 2. Square root of 9 is 3. That becomes p. So we have p is equals to 3 square root of 2. Now, if these two lengths are equal, then that tells me that x plus r is also equals to 3 square root of 2, and x has to be equal to 3 square root of 2 minus r. Now, let's concentrate again on this small square here where we have r, and x. Therefore, we have x squared is equals to r squared plus r squared, which is equals to 2r squared. Therefore, x squared, the square root of that, which is equals to square root of 2 dot square root of r squared. That becomes r, that becomes x. Therefore, x is equals to r square root of 2. Two values for x. So let's equate them. We have r square root of 2 is equals to 3 square root of 2 minus r. Therefore, r square root of 2 plus r is equals to 3 square root of 2. And we go that say that r outside of square root of 2 plus 1 is equals to 3 square root of 2. Therefore, r is equals to 3 square root of 2 over square root of 2 plus 1. This is the very same answer as in method number 1. Now, let's look at method number 3, which I call the direct method. Now, remember I said that we can break this into 4 different squares, all right, which this is 3, and every length is 3, and we know that this is 6. So this is 3, and let's concentrate only on this square. And we can bring this here, and we know that this is r, and this is x, and this is 3, like we said, and this is 3. So let's concentrate on this triangle right here, and we'll say we have 3, we have 3, we have x plus r. Therefore, we have x plus r is equals to 3 squared plus 3 squared. Then we have x plus r squared is equals to 9 plus 9, which is equals to 18. Therefore, x plus r squared to the square root of this is equal to square root of 18, which equals square root of 9 dot square root of 2. That becomes 3. That becomes x plus r. Therefore, x plus r is equals to 3 square root of 2. And we can equate that to x is equals to 3 square root of 2 minus r. Now let's concentrate again on just this little square right there, which is r and r. And let's bring it on. So we have here, we have r, and this x. Therefore, we have x squared is equals to r squared plus r squared, which is equals to r squared. Therefore, the square root of x squared is equals to square root of 2 dot square root of r squared. That becomes r, that becomes x. Therefore, x is equals to r square root of 2. We have two values of x. Let's equate them. So we have r square root of 2 is equals to 3 square root of 2 minus r square root of 2 plus r is equals to 3 square root of 2. Therefore, r outside of square root 2 plus 1 is equals to 3 square root of 2. Let's divide both sides by square root of 2 plus 1. Therefore, r is equals to 3 square root of 2 divided by square root of 2 plus 1, which is the same answer as in method 1 and method number 2. The reason why I use three different methods to solve this, I want to show that math is very versatile and everyone sees things a little different. But one thing you will appreciate about math is if you do it correctly, no matter what method you use or what system of equations you use, you should all come up with the very same answer. With that said, thank you very much for staying with me for the solution to this problem. If you are interested in more solutions like this, please like this video, subscribe to the channel, leave me a comment, and let me know if there's another way you would solve this problem. Have a great day.